Hello and welcome to a video on triangle proofs, and these proofs are going to go a step farther than proofs that we've done before where we've only proven that two triangles are congruent, and now we're going to prove one step past that using cpctc. So let me first remind you what cpc stands for. Think about it for a minute, see if you can figure it out. Remember, actually. Okay, I hope you got it right. Okay, so when we're doing these kinds of proofs, so when you're asked to prove that parts are congruent, parts of a triangle are congruent, you have to start by saying that the triangles themselves are congruent. First, you must prove the triangles are congruent. Okay, so in past proofs, I almost have this right. Okay, in past proofs, the prove line has asked you to prove that two triangles are congruent, not angles, but triangles. Now, if you look at this first proof, the second proof is not about triangles, but it's about sides. The third proof is about angles. These are all going to be sides and angles. None of these are going to be about proving triangles are congruent. But like I just said, in order to prove the parts are congruent, you have to start by proving that the triangles are congruent. Okay? So that's going to be our approach. So that means the last line will still be stating what we want to prove, but the line right before it, that's going to be stating the triangles that are congruent. And now if you look at the examples, I'm only going to probably do one or two here. They only have two triangles in them. There's not a lot of choices. So we have to use those two triangles. It'll keep it fairly simple. All right, so let's start out by doing what we always do, which is marking the diagrams according to what's given. Okay, so in this first case, why don't you see if you can mark everything on the triangle, and then we'll lay out the proof. Okay, so there's the three marks on the triangle, and I'm going to write the two congruent statements that are given as two separate statements. So AB is congruent to AD. That's why, because it was given. BC is congruent to DC, also given. And those are both the first two things that are marked on the diagram, but also I marked that AC is congruent to itself. And remember, we have a couple ways that we can say why that's true. We can just say that it's the same side. We can also say the reflexive property. Either one of them is okay. Okay? You don't have to write both. I'm just showing you both options. All right, and we now can see that two triangles are congruent because of side, side, side. So we can write the congruent statement. Triangle ABC is congruent to, let's see, A goes with A, so triangle ADC, and that's because of side, side, side. All right, so far, now if that was only what we wanted to prove, we'd be done. But we have to go one step farther, and if you look at the triangles, angle BCA, this angle right here, and angle DCA, this angle right here, they are corresponding parts, and therefore they are congruent. So because the triangles are congruent, we know that the corresponding parts are congruent. Another place you can see that is right here. The C's are in the same spot corresponding in the statement. So that enables us to say that those two parts are congruent, and that's what we want to prove. So now we can say our final step, angle BCA is congruent to angle DCA. And why are they congruent? Because of cpctc. So as a rule, when we're doing a proof of something other than triangles being congruent, either sides or angles being congruent, the step right before the last step is going to be the triangle congruence that we always have to do first, and then the last step will be what you see right here will be what you see in your last step. And then the reason will be cpctc. These two will generally be a shortcut and cpctc. Okay? Let's try the next example. Okay, so we can start off by marking the diagrams. We can start off by writing the statements. Either way, we've got to do both. So let's just go ahead and think about it first and mark the diagrams first. So let me first mark this parallel statement. PS is parallel, and I'm not going to mark them congruent, I'm going to mark them parallel. That's not enough for part of our shortcuts. It's not a congruent sides. It's going to lead to congruent angles, as hopefully we know that by now. I'm going to also write that in here. So PS is parallel to QR because I was told it was. It's given. All right, let's go on to the next one. So I've got, actually, before I go on to the next one, maybe I should just go ahead and figure out what is congruent because of those. Well, let's make the only z that we can make because of this, and it's right there. There's the z. And so the angles that are congruent are this angle and this angle. So I may as well say that, and that's because of AIA, alternate interior angles. So I can now say angle PSQ is congruent to angle RQS, just the same two angles that I just marked, because alternate interior angles are congruent. Now, when I say that, we mean when the lines are parallel, but we're still just going to write that shorter way. Okay? We don't have to say when the lines are parallel. All right, let's go. We got one thing marked, one congruence marked. We've got another congruence that's stated in the given, so we may as well write it down. So we can say angle QPS, I'm writing exactly what I see in the given, is congruent to angle SRQ. And that is given. That's two things. Now I may as well, let me write them as congruent. So QPS is this angle here, and SRQ is this angle here. Now I've got one more thing I can pull out of the diagram, and I'm going to do that in this color, and that is the same side. And so let me say it, let me write it. So SQ is congruent to SQ. So this is same side. And now I'm ready for observing here that I've got angle, angle, side is congruent to angle, angle, side. So there's my shortcut. I'm able to say the two triangles are congruent. So triangle, let's see, PSQ, how about QPS? I'm just trying to go in alphabetical order. I went backwards, didn't I? That doesn't matter. So QPS, the P comes before Q. I was just trying to do the first letter in the alphabet first. But anyway, Q corresponds with S, just looking at the marks on the triangles. P corresponds with R, and S corresponds with Q. And the reason for that is angle, angle, side. And now, like I said, that, just like I said up here, that will typically be the step right before our triangle, our final, what we're trying to prove, our final statement. That's where you're going to see the triangle congruence, and that's where we see it here in step 5. Only there's one more step because we still haven't said what we're trying to prove, which is that PQ is congruent to RS. And the reason for that, just like the last one, just like every proof that we use CPCTs, it will be our last step by CPCTC. All right, I hope those examples helped, and let's see, what can we say to review this? So notice that the given information is first, except for in the second problem, after I wrote the given information, I thought about how that was not a congruent statement, so what congruent statement does it lead to? And there's a flow of logic here where it has to come, this statement number 2 has to follow after statement number 1. It's because there's parallel lines that the alternate interior angles are congruent. Okay, hope you found this helpful.